Hey, welcome to the Chats. As a CTO or tech leader, you have been tasked to transform your application or architecture into the famous word cloud native architecture or cloud native first. But what's this term? What are the features, patterns, and principles to adopt this type of architecture? Well, let's clarify on this video how works a cloud native architecture. Now that I got your attention, I'm Alfonso Valdez from Clickit, a nearshore DevOps and software development company that helps SaaS and fintech companies to extend their tech team through dedicated nearshore developers. So guys, let's start defining what is a cloud native architecture. Well, a cloud native architecture is a combination of methodologies from cloud services, DevOps practices, and software development principles. It as well abstracts all IT layers from networking, servers, data centers, operating system, firewalls, and that could be multiple layers or multiple IT layers into one single layer called the cloud native layer. As well, enables to transform your application into a continuous transformation from used to be virtual servers, cloud instances, microservices, serverless, and managed services. And lastly, it allows you to focus on your features, developing those, and not managing servers or infrastructure. Cloud native architecture features and benefits. Number one, it helps you accelerate your software development lifecycle. Since you are using a lot of pre-configured or pre-built cloud services, well, obviously, it helps you to reduce your SDLC. Number two, as an entrepreneur, you love to build MVPs. Well, being cloud native, it helps you increase your time to market. Because of the same reason on the point number one, well, you have multiple services already built. It's easier to build MVP from months, 3, 4, 5 months, into 1 or 2 months. Number three, it helps you turn your apps into API-based applications. Being the cloud or cloud native first, you will be using a lot of APIs. It's important that your application as well acts as an API system to interact or integrate into different processes or into the different cloud native processes that you might have. Number four, it helps you reduce downtime and reduce failures. Since you are relying a lot of the services in the cloud, in a cloud native architecture, well, you don't need to worry about downtime and failure because those services are already built, tested, and free of bugs. Point number five, it helps you pinpoint issues more easily. Since you are using microservices, serverless, or a decoupled architecture, it helps you identify errors more easily instead of when you have a standalone system or a single server with all the services where when you have a problem or a failure, you don't know where to start. Now, with a decoupled architecture or separated system, let's say distributed microservices or microsystems, it's easy to identify if it's an API, it's the backend, the front end, the API, another third-party service, or whatever other service. Number six, since you're reducing your times, well, you lower your costs, or your implementation times get reduced dramatically, and it helps you with the man hours, meaning reducing costs. Now, patterns and principles of a cloud native architecture. Principle number one, auto-scaling and elasticity. If you are using a cloud provider like Amazon Web Services, Azure, or Google Cloud, their main premise is that they are elastic, available, and reliable. That are the core features of a cloud provider. Number two, utilize the 12-factor methodology. It's a huge paradigm from using a source control system like GitHub or Bitbucket. Another point is that you need to have a decoupled architecture. Also, you need to isolate your dependencies by not including your libraries or your configuration dependencies inside the code repository. Instead, move those dependencies outside of that control. Number 4, make sure to include a continuous integration and continuous delivery pipeline, which is paramount in the DevOps world. Another thing that is huge and important is that your application should be stateless. And another term, you need to have an immutable infrastructure, or that your environment is disposable. Another term that is important from the 12-factor methodology is that you need to have a loosely coupled architecture. And lastly, is that your dev, testing, and production environment should be identical. You could use containers, Docker, and microservices. Principle number 3, automation and infrastructure as code. This principle allows you that your infrastructure to live in code repositories, again, in Bitbucket, GitHub. It helps you manage your infrastructure with config files, fully versioned, or your code or your infrastructure treated as pure code as your applications. It as well enables you to infrastructure to be easily repeatable and versioned, so you can share it and reuse it whenever you need it. Point number 4, immutable infrastructure or immutable code deployments. By having that, you can automate your deployments using a CI/CD and launch new products environments without human configuration, meaning bringing new resources fully automated and ready to consume traffic with the latest software, latest configuration, and latest code. Now, point number 5, self-service infrastructure or infrastructure as a service. Another characteristic of being cloud native is that your infrastructure should be in an IaaS model, where you can control your IT resources, your IT infrastructure, and it's totally a self-service infrastructure without having to ask for permission or make requests for a resource. Number 6, cloud managed services. Use as much as managed services as you can. Why you should use an AWS managed service like Amazon Cognito, Amazon RDS, or Amazon Fargate, etc.? Well, there are huge benefits where building a service from taking several weeks into a few hours when you are integrating those managed services. Number 7, pay as you go or pay per use infrastructure. This distinction has the ability to control your expenses and renting your cloud native infrastructure on demand instead of paying something upfront, like when you are renting servers or paying for a 1-year server on-premise on a data center. Well, in this case, you can pay on demand. The pay-as-you-go model allows you to optimize your cloud resources whenever you don't need them and have a flexible and elastic infrastructure in terms of cost. Just pay your cloud-native resources when are being used and not when they are in idle. Number 8, serverless computing. This is the pure model of a cloud-native architecture where you consume functions and resources per milliseconds or seconds without having to manage any server. This is another disruptive ecosystem where dividing your business unit or your algorithm into a serverless architecture, which allows you to reduce costs and you can have a pure cloud native model. So at this point, ensure that your cloud native architecture begins to use serverless ecosystems such as Lambda, Amazon API Gateway, Amazon Aurora, etc. And finally, you can use, or a use case for the serverless ecosystem is to, let's say, use a data processing algorithm to build an API, or just to use your serverless with batch jobs. Number 9, the latest, event-driven architecture. This architecture is a complement of the serverless architecture, simple as executing system or isolated services in response or triggered by events. By automating this process, it allows you to reduce dramatically your cloud costs. As you can see, from the principle 1 to 9, you are abstracting or reducing your IT layer into a single one and trying to reduce a lot of costs from auto-scaling, microservices, serverless, and event-driven architecture. So finally guys, what are the tools or drivers to create a cloud-native architecture? Some of them you might know. So imagine that we have a cloud-native application where it's monolithic and you would like to move it to the cloud. So in the left side we have the cloud provider, which is Amazon Web Services in this case, but you can use Azure or Google Cloud. Then map out all the services you have, databases, jobs, caching systems, and see what can be managed by the cloud. Let's say if you have a database, maybe you can use Amazon RDS with Postgres or MySQL. If you have a file system service, you could use Amazon S3, and so on. So one, you have identified the managed services as a step 2, then move to the step 3, which is build or create a microservice architecture within your application, and those tools you can use Docker and containers, which is the correct word on that. Then if your application is highly scalable, you are getting a lot of traffic, a lot of users, or a lot of subscriptions, well, maybe you can move or you can port your containers into a container management system, which in this case can be Kubernetes. In Amazon, you can use Amazon AKS, Amazon ECS, or Amazon Fargate. Then the pieces that can be decoupled, let's say complex algorithms, jobs, batch processing system, those can be put in a serverless ecosystem. In this case, the tools are Amazon Lambda, Amazon API Gateway, and Amazon Aurora Serverless. And finally, you could use an event-driven architecture which works with the serverless ecosystem. In this case, the tools are Amazon Event Rich, Amazon SQS, and Amazon Lambda. So to conclude, are you cloud native or not? If not, what are you waiting for? Just join the continued digital transformation with us. Now, to find out more about how Clickit helps SaaS and fintech companies to develop those practices in the cloud, or just curious about hiring a niche or software developer in your same time zone, please check out our website at clickittech.com. Please don't forget to subscribe to our YouTube channel and comment below any comment or principle that I missed, and let's contribute to our network. Hasta la vista, amigos. Adiós.